Today's problem string is called double the dimension, double the area. I'd like for you to take a moment to write down this heading as well as these 3 problems or expressions. Make sure to leave some space so that you can jot down some extra notes. When thinking about this problem string today, what I want you to think about is each time we go to solve a problem, I'd like to represent that problem with a rectangular array. So in the first problem, 4 times 3, let's go ahead and draw a rectangular array to represent that. So I'm going to go ahead and I'm going to place this image here that I already drew. And if you can go ahead and draw this as well. And I just want to remind you, as we discussed earlier, area equals length times width. So when we're thinking about using a rectangular array or the area model to solve a problem, this is what it would look like. Okay, so as you can see, there are 3 rows and 4 columns in my rectangular array. So I'm going to write down, to represent these sides, what each side's value is. So I'm going to come over here and I'm going to write 3 by 4. Now, if you drew yours with 4 by 3, you just want to make sure you put the correct dimensions in the correct locations, okay? And obviously, we know what 4 times 3 is, hopefully. 4 times 3 is 12, okay? So the reason why it's important to annotate this inside of your rectangular array is because when we go on to double the dimension, double the area, so there's going to be something we're going to do down here and we're going to be looking for a connection or relationship. I really think it's important that your pictures help demonstrate the work that you're going to do so that you can help visualize this. Okay, so now it's your turn. I want you to go ahead and make a rectangular array for 4 times 6 and also do the same thing for 8 times 6. And then we'll have a discussion. Okay, how did you do? Hopefully your 4 by 6 looks something like this. I decided to go off of my original rectangular array so that I can have 4 as my width, let's call this, and the side was my length, 6. Maybe yours is flip-flopped, so your 4 might be on this side and your length of 6 might be on this side. So either one doesn't matter because of the commutative property of multiplication, right? Now let's go over here to 8 by 6. What were you thinking for your 8 times 6? How did you draw that? So for me, I'm lucky enough to be able to use this tool. So I was able to copy my original, and I was thinking of something that I can do. And I don't know if you thought of this when you were making your rectangular array, but I know that 4 and 4 is 8. And if I were to add 2 of these or place 2 of these side by side, that this would be a width of 8, right? I have 8 columns and I have 6 rows. So this is a 6 by 8. Interesting. I wonder how that's going to affect my answer. Or my product. Let's think about that for a second. Did you notice that my 4 by 6 is basically 2 4 by 3s? So I'm going to go ahead and stack these or double these. See that? So I have 6 rows and I have 4 columns. So it's a 4 by 6, but this just has turned into a 4 by 6 array because I've doubled it, right? So I've doubled the dimensions of this original, and my area, in effect, is also doubled. So let's think about that as we are working on the next problem, which hopefully you've already solved, but if you haven't, I want you to be thinking about in your mind how this same problem could be represented. We can do the same thing here, like so. So if we knew that 4 by 6 was 24, and once again, another 4 by 6 is 24, then this entire area of this one array, rectangular array, is going to be 48, right? Okay, let's jot down a couple more problems. I'm going to have you do a couple on your own, but before I do, I'd like to look at this 4 times 12 and 8 times 6. I'd like to think of another strategy we can use because in this particular problem, I'm doubling one of my factors. So I notice here that 6 and 12, well, 12 is twice as much as 6, so I've doubled 6, but 8 is not the same. So 8 has been halved, right? Because 8 divided by 2, or in half, is 4. So can anyone think of a strategy maybe they've learned before that might help them with this problem? Were you thinking doubling and halving? Because that's what I was thinking. Okay, so before we go a little bit further and start solving this problem, I want to make sure that I point out that it's really important when we're writing expressions and then solving them with a model of some sort, in this case a rectangular array, that we write a number sentence next to it with our actual solution to our problem, just because it helps keep work organized. And sometimes it's also a way to check our work, because we may have not added these two numbers, and if I were to see this work, I might not know what you're telling me the answer is. So I want to make sure that we always remember to write the number sentence next to our work, okay? But let's go back to this problem, 4 times 12. So we were talking about these relationships and doubling and halving, right? You might remember the strategy of doubling and halving from 4th grade. Maybe not. But in any event, I would like to think about the other relationships between these other numbers. Can you notice anything? Here's what I noticed. I noticed that 4 times 12 and 4 times 6 are related in the sense that 12 is twice as much. It's double, right? It's double 6. So I can take my information from this problem and just double it, right? Because my area is also going to be doubled. So I'm going to go ahead and I'm going to use the easy way. I'm going to take the work that I already did and I'm just going to place it right there. Why don't you take a moment to copy these notes down and we can have a discussion. Great work today. We spent a lot of time talking about relationships, and I want to let you know that we're going to be spending most of 5th grade talking about number relationships. And this problem string, double the dimension, double the area, we really talked a lot about looking at one of the factors or dimensions, and when it doubles, how that affects the area. So in the first problem, 4 times 3, our rectangular array we drew showed that the product was 12, or the answer is 12, or the area is 12. Now, in the next problem that we did, 4 times 6, one of my dimensions doubled, and that also affected my area. So my area then doubled. Okay, now I'm going to give you some problems that you can solve on your own. Here are the 3 problems you're going to solve on your own. Remember, double the dimension, double the area is the strategy we used today. But we also talked about doubling and halving just a little bit.